Well, actually, I got a gift to you guys. I have 3 additional practice questions, so that may be helpful. Unless you guys want to say, no, we got enough practice already. Let's move on. Then we can go ahead and move on. All right. Let's go ahead and get started. It's time already. Do you guys have any questions? Did anyone study over the weekend, over the past 4 or 5 days or so? Okay, very good. Any questions from studying? Any particular topic that kind of pops out and say, well, we might need to cover that again, or specific questions? Yep.
It's like, I remember we covered something that was like, you were talking about an entire trace, and you were saying this is a post, and it's different between a post and a pre type conditional statement. I'm not sure. You were saying something like, oh, it's giving you the condition before.
It's giving me the condition before.
I remember something like that.
I don't remember that either. Can you kind of pinpoint which day we talked about that? Because I have some of the notes, already captured on Moodle, so that could be helpful.
I'll remember.
Okay. Well, you got to do it today because we have the test on Wednesday. Okay. Any other issues? Yep. Go ahead. Yes, but at this point, I would be conservative and just say that prepare to use only printed or handwritten material. Okay. Any other questions? Yes. Mm-hmm.
And the thing we did last time, we have a 4-line code that says x gets 0 while x less than 3, do x gets x plus 1 and while.
Mm-hmm.
When we reach post 3, we have to substitute.
Are you talking about not the test, but the in-class material that we talked about last time?
Yeah.
Okay.
When we reach post 3, we have to substitute something. And I'm not sure how to get an operation here mathematically. It says x minus 1 less than 3, and that turns into x greater than or equal to 3.
Okay, I see what you mean. Let's handle the practice test first, because what you asked me is the loop invariant for loops. And loops are definitely out of the scope of this test. In fact, it's out of the scope of any test. So the whole concept of loop invariant is only there just so that you guys have some exposure to it. Okay? But what you ask is, probably something that I want to explain also, because it is, it's useful to understand that. So I'll go ahead and cover that also today. So remind me to do it, if I don't have time to do it. Okay, so I'll go ahead and get started with the test first. Okay, so the practice exam 1, more questions, is actually online already, but I did it fairly late. So most of you probably did not have a chance to actually see it, when it's posted. So here we have, question 1 is once again a trace type of question, and this time we have a seemingly longer program. But just because the code looks longer does not mean that it will take more time to trace, because you can see that this portion is a conditional statement. So as a conditional statement, it means that sometimes it will go through that, and other times it may not go through it. So let's go ahead and take a look at this one. And the next one is a conditional statement also, but that one is a pre and post condition thing. So we'll take a look at that one after the first question. I will go ahead and just type in my answer next to the question. So if you guys want to practice and not really see the answer, but try to come up with your own solution, you can go ahead and just kind of hide the other one, or scroll it so that it does not show the answer right away. Okay, this one should not be a big problem. I'm testing in addition to whether people understand a loop, whether people understand how a conditional statement works, and is a conditional statement inside a loop, and is more special than a regular conditional statement. So let's go ahead and trace this program. And once again, we have comments, we have line number, and in this case, we also have just two variables, x and y. I found that it's easier for me to use tables, so let me just switch to a table format instead.
It's going to be posted, right?
Yes, I just have to remember to save it. So can you guys remind me to save it? Because there's a class right after us, so sometimes I will be in a hurry to leave the classroom and reset the computer before I have a chance to save it. Now, if I'm dealing with OpenOffice, it will prompt me and say you haven't saved the file. You want to save it before you shut down the computer. But since this is on a browser, it does not really automatically trigger that mechanism. So I can't really do it the same way as with a Office document. So just remind me at the end of the class. So we have comments, we have line number, we have x, and then we have y. Okay, there we go. All right. The precondition is we don't know anything about the initial values of x and y. That is already given. So as a result, you should write down the precondition is we don't know anything about x, we don't know anything about y. Okay. In other words, sometimes I don't have to spell out the first row of a trace. If I say that we don't know anything, you just put in question marks automatically. So now we can insert more rows into the table. Okay. Insert after. That's before, that's after. There we go. I'll probably need a few lines like there. What does line 1 do? This gets a little bit more challenging. I can do it like, sort of like that. Okay, let me, just hold on a second, let me reformat. There we go. So now we have two windows again, and we can see what's going on in one and focus on the other one. Okay, on line 1, what do we do?
Update the value of x to 1.
Update the value of x so that x becomes 1. Very good. On line 2, we update y, but this time, remember, x was initialized to 1, y is initialized to 0, so it's different. And now we have line 3. Line 3 is a conditional statement. We ask, is y less than 2? The answer is true. So then we move into the loop, so we go to line 4. Line 4 is adding 30 to x and put it back into x. X started with a value of 1, so now it becomes 31. Then we go to line 5. Line 5 is asking, is x greater than or equal to 31? The answer is true, okay? Because it's greater than or equal to. So that means we have to go to line 6. What does line 6 do? Line 6 says, we want to decrement x by 31. X is 31 at this point. 31 minus 31 is 0. So x now becomes 0 again. And then we go to line 7. Line 7 adds 1 to y. Y is now incremented from 0 to 1. Now, what do we do? This is the question. Because we are simultaneously at the end of a conditional statement and also at the end of a loop at exactly the same time. Okay? We go back to line 3. Very good. Okay? Does everybody understand why we are going back to line 3 after the statement on line 7? Okay? If you want to draw a picture, you have to remember how to draw a picture like this. So we have a usual, pre-checking loop like this. So we have a way to branch in, and now we have an operation here. This picture should be fairly familiar to everybody in the class at this point, right? This is a pre-checking loop, a picture of one. We have a statement inside here that doesn't really do anything. It does not branch. All it does is to add something to one of the variables. The second statement inside the loop from line 5 to line 8 is a conditional statement, which means at this point we branch out into two possible paths. And in this case, we only have the then branch. The else branch doesn't do anything. So these two branches will merge before they exit. That's the shape of the overall structure. So that means when you're done with a conditional statement, you have no choice but to go all the way back to the beginning of the loop itself and ask the question, should I go for another iteration? Are we okay so far? Okay. So in this case, after line 7, I do not trace line 8, I do not trace line 9, because both of these are ambiguous. Okay. Yep.
So if y is if line 5 had been false, then do we end the entire thing? Or?
Well, we'll see. Okay, we'll see, because according to this, if the condition is false, you simply bypass the right-hand side. You bypass the left-hand side using the right branch here, but you still have to go all the way back to the beginning. Remember this picture. This picture does represent the logic of that pseudocode. Okay. So now we go back to line 3. Line 3 is still asking the same question. Y is less than 2 is true because 1 is less than 2. We add a few more lines. Then we go to line 4 again. Line 4 is adding 30 to x, but x is now 0. 0 plus 30 is 30. And so we use 30 to update x in this case. And then we move on to line 5. Line 5 is asking, is x greater than or equal to 31? That is false. Very good. So if that is false, what do we do? According to this picture, okay, according to the picture, what are we going to do next? We go back to line 3. Okay, we go back to line 3. So we go back to line 3, and then we ask the same question again. Y less than 2 is still true at this point. We did not touch y in the previous iteration. We changed x, but not y. So y is now updated to y is still less than 2. We go into the loop again on line 4. Line 4 is adding 30 to x. X was 30 already. 30 plus 30 is 60. So now it is updated to 60. And we need to add a few more lines here. Maybe one more. Then we move on to line 5. Now, why do we go from line 4 to line 5? It's a trivial question, but I do want to make sure that you guys understand that. Because they're in the sequence. Okay, because it's in the sequence, you have one statement here, the next one is right next to it. So in this case, we just have one statement following the other one. Okay. Is x greater than or equal to 31? Yep. So it is true. We go in when we go to line 6. Line 6 is going to subtract 31 from 60, which makes it 29. And then we go to line 7. Line 7 is going to add 1 to y. Y goes from 1 to 2. And then a few more lines to go. Then we go back to line 3 again, because line 7 is basically corresponding to this statement here. After it is done, we have to go all the way back to line 3. We ask the same question again with the loop. Y is less than 2 is finally false. And since there's no statement after line 9, I would use post to indicate this is the end of the entire trace. Yep.
I remember what I was trying to say. So I just wanted you to define the difference between a pre-checking and a post-checking loop.
A pre-checking loop, checks the condition before it performs the operation. A post-checking loop, which is a repeat until in this class, will check the condition after you perform at least one iteration.
Oh, okay.
Yep. Now, just to stay on the save side, what I'll do is I'm going to save this first. Okay, so I'm going to have to close that window and go here, save it once, so that this way, even if I forget to save at the very end of the class, we will have this question already saved on Moodle. And we'll go ahead and go back and re-edit. So this way, it's basically just saving it on a regular basis. Okay, here's question 2. Question 2 is to derive the post condition of the last line of the following pseudocode. Be sure to show and explain all the steps. Now, since I did not give you a precondition, if I did not give you a precondition, can anyone guess what the precondition will be?
True.
Just true, because I'll just be saying